Good morning, sir. I am lovely Dianne Ganub Duron, Bachelor of Science in Social Work, third year B. So, summary discussion about the historical developments of statistics. Simple forms of statistics have been used since the beginning of civilization, when pictorial representations or other symbols were used to record numbers of people, animals, and inanimate objects on skins, slabs, or sticks of wood, and the wall of caves. Before 300 BC, the Babylonians used small clay tablets to record tabulations of agricultural yields and of commodities bartered or sold. The Egyptians analyzed the population and material wealth of their country before beginning to build the pyramids in the 31st century BE. The biblical books of Numbers and Chronicles are primarily statistical works. So the formal containing two separate censuses of the Israelites and the latter describing the material wealth of various Jewish tribes. So similar numerical records existed in China before 200 BC. The ancient Greeks held censuses to be used as basis for taxation as early as 594 BC. So the Roman Empire was the first government to gather extensive data about the population, area, and wealth of the territories that it controlled. So during the Middle Ages in Europe, few comprehensive censuses were made. So the Carolian kings, Pepin the Short and the Charlemagne, ordered surveys of ecclesiastical holdings. So Pepin in 758 and Charlemagne in 762. Following the Norman conquest of England in 1066. So William I, King of England, ordered a census to be taken. So the information gathered in this census conducted in 1086 was recorded in the Domesday Book. So some scholars pinpoint the origin of statistics to 1662 with the publication of natural and political observations upon the bills of mortality by John Grant. So early applications of statistical thinking revolve around the needs of states to base policy in demographic and economic data. Hence, stat etymology, the scope of the discipline of statistics, broadened in the early 19th century to include the collection and the analysis of data in general. Today, statistics is widely employed in the government, business, and the natural and social sciences. So because of its empirical roots and its focus and applications, statistics is usually considered to be a distinct mathematical science rather than a branch of mathematics. So its mathematical foundations were laid in the 17th century with the development of probability theory by Blaise Pascal and Pierre de Fermat. Probability theory arose from the study of games of chance. The method of least squares was first described by Carl Friedrich Gauss around 1794. So the use of modern computers has expedited large-scale statistical computation and has also made possible now methods that are impractical to perform manually. So G. Ahenwall is usually credited with being the first to use the word statistics. But statistics, in the modern sense of the word, did not really come into existence with the publication. In this book of systematics attempt was made to make use of a class of facts which up to the time that have been so examples that illustrate each of the uses of statistics. So statistical studies are extremely important in our everyday life. Statistics are the method of conducting a study about a particular topic by collecting, organizing, interpreting, and finally presenting data. So every human at some level is a statistician. So statistics helps in providing a better understanding and exact description of a phenomenon of nature. So it also helps in the proper and efficient planning of a statistical inquiry in any field of study. So statistics also helps in collecting appropriate quantitative data.
So this is the solving. So N1 mo ni ang formula. Dayon N1 divide N close and open parenthesis times N. So atong N1, the first year, the given number is the given is first year, so 3,400 divide 720. Ang 7,720 nakuha ni siya sa first to fourth year nga add tanan. So mo ni siya ang result 7,720. So kung atong 3,400 ato siyang i-divide into 7,720 mo ang iyang kuan is 0.44. So 0.44. Tapos kay mo man niya atong formula nga sundon, so i-times na siya, i-times into 200, which is ang atong iyang selected number nga gihatag sa tuina na to. Then imo siyang i-times 0.44 times 200 is equal to 88.1. So mo na siya ang answer. So second year. So kay second year man, N2 is equal to open parenthesis N2 then N then times N. So N2, so ang given number sa second year is 2,100 divided by 7,720 is equal, ang result niya is 0.27. So katong 0.27 ato siyang i-times into 200. I-times na to siya into 200. So 0.27 times 200 is equal to 54.4. So mo ni ang second year. Another one is the third year. So N3 is equal to, ang given number sa third year is 1,500. I-divide nimo into 7,720 again time 1,500 divided by 7,720 is equal to 0.19. So 0.19 katong 0.19 ato siyang i-times na pod into 200. So ang result niya is 38.9. So mo na siya ang answer. Then another one is the fourth year, the last one, fourth year. So N4 is equal to 720 kay 720 man ang given sa fourth year, i-divide na po na ito siya into 7,720 which is ang iyang kuan. Tapos times 200 dayon muna to 18.7 ang fourth year. And solving is the large size. So the large size given number is 2,400 divided by 12,000. The total is equal, tapos i-times nimo into 1,200 the given sample size. So ang result niya is 240 large size. Then into medium size, 4,200 ang given number sa medium size. I-divide nimo into 12,000 the total times 1,200 the sample size. So ang result niya is 420 medium size. Then number 3 is 2,400 the small size given number divided by 12,000 the total times 200 is equal to 240 small size. Then last one is 3,000, the compact size given number. Tapos divided by 12,000 the total times 200 is equal to 300 compact size. So number 4, 6, 7, 10, 5, 5, 8, 8, 3, 6, 9, 5, 7, 3, 12, 14, 2, 5, 3, 5, 8. So sa 20 numbers, imo siyang i-divide nga mahimong 5 groups. So the last number nga imong maihap sa kada group mo'y answer sa N. So since 20 man siya ka number, ato siyang i-divide into 4 para mahimo siyang 5 groups. So 6, 7, 10, 5. So 5 is the last number, mo'y answer sa N1, 5. So 5, 8, 8, 3. Ang last number is 3, so mo siya answer sa N2. So 6, 9, 5, 7, third group. Ang last number nga mayap nimo sa third group is 7, so mo siya nasa N3. So 3, 12, 14, 2. Fourth group, 2 is the last number, so diri siya ibutang sa N4. 5, 3, 5, 8. Ang 8 ang last number nga iyang ang last number, so diri siya sa last group, which is the fifth group. Diri ibutang sa N5. So that could be all. So number 5. Suppose we wish to sample the opinions of all heads of families in a city or municipality on some issue, and further suppose that the city or municipality has 10 barangays. So it is difficult to obtain a frame listing of all families within the city or municipality. But suppose each barangay possesses a list of families. How could we proceed? So for me, we proceed by using the cluster random sampling, in which this is used whenever the population is widely dispersed geographically. So, and also, this sampling process is used very extensively in sample surveys by government, municipalities, and barangays. Number 6. How should one proceed in sampling the opinions of heads of families in a city where for one reason or another are not listed on zone rows? So, one proceed in sampling the opinion of heads in a city where for one reason or another are not listed on zone rows by using or making survey population. So we could ask why he or she is not in the list. So that could be all. Thank you, sir, and